So TMUA occasionally asks you to expand objects like this, which isn't really binomial expansion because, of course, binomial means two numbers, and this is three numbers. And so the expected way of you doing this is to like group two of them up, like this 1 plus x, treat that as a single object, and then do binomial expansion. But then you have more expansion to do because you'll have like a 1 plus x to the sixth term, and you have to expand that as well. And that's quite time consuming. It turns out there's quite a nice trick for this, and when you've got multiple numbers, more than two inside the bracket, called multinomial expansion. We're going to focus on when there are three of them, though, because that's all TMUA has ever asked. You'll see that it's very easily generalized to four after you've seen it. Anyway, let's just learn the trick. So let's just, I'm not going to stand out this whole thing because I can't bother. Let's just think about the a cubed b squared c squared term. Just that term there. I just want to find the coefficient for that. Well, these, of course, seven brackets are written out like this. And, of course, the a to the 7 term, there's only one of those because it's almost like you have to bounce along all the a's, and there's only one way to do that because you have to take all the a's. Whereas if you were looking for like the a to the 6, b to the 1 term, of course, you could take the first 6 a's and then the last b, or you could take the first b and the other 6 a's, and then, of course, you could mix it up. There are, of course, 7 ways to do that because there are 7 b's to choose from that you could group with the other 6 a's. So if we're thinking about this term here, all we have to do is say, okay, well, from these 7 brackets, let's choose 3 a's, because that's what we need, right? So let's just choose 3 a's. That's 7, choose 3, obviously. Now, we've only got 4 brackets left, because 3 of them have had the a selected from them. So we only have 4 brackets left, and we need to choose 2 b's. Well, that's just 4, choose 2. And then finally, the c's, there's only 2 brackets left. We need 2 c's. There's obviously only one way to do that. But for completion, we'll just write 2, choose 2 here. And this is going to be the coefficient. And that's all there is to it. We've just done it like that. And of course, this choose function works like this. It's n factorial over k factorial, n minus k factorial. So this is 7 factorial over 3 factorial, 4 factorial, 4 factorial over this, and so on, and this here. Now, of course, what goes quite nicely about this is that these two 4's cancel, these two 2's cancel, 0 factorial doesn't matter because it's just 1. And we end up with 7 factorial over 3 factorial, 2 factorial, 2 factorial. And notice how this relates to the original question. This 7 factorial is just the n that we're expanding to, and the 3, 2, and 2 just refer to the numbers of each thing we had to take to make this work. So okay, that's pretty cool, and we can calculate this pretty easily as well. I'll just call that this notation. I don't think I'm going to use this notation again, so it's kind of pointless, but it's kind of like 7, choose 3, choose 2, leave 2 behind, something like that. I'm not going to use it, so it's kind of irrelevant. But anyway, the general form for this, though, if we're doing a plus b plus c to the power n, will be, if we're looking for the a, I, b, j, c, k term, will be n factorial over I factorial, j factorial, k factorial, as long as I, j, and k add up to n. Because, of course, you've got to take something from every bracket. And so the amount of something is all going to add up to the total number of brackets, which is n. So as long as that's true, we're fine, and this will work. The one last thing that I want to mention, though, of course, is what if expanding something that looks like this? Well, we're going to do the same thing for the part of the coefficient, right? 7 factorial over 3 factorial, 2 factorial, 2 factorial. However, when you take 2 b's, of course, that's going to be 2b all squared. And when you take 2 c's, that's going to be 3c all squared, just like in regular binomial. And so, of course, this 2 squared and this 3 squared, which make 4 and 9, is going to impact the entire coefficient. So we can calculate this first. Of course, you've probably practiced lots of this in preparation for TMUA anyway. But when you're doing these factorials, lots of things cancel. It's like 3 times 2 times 1 goes away with 3 times 2 times 1. You want to do as little work as possible. 2 times 2 is 4, so that all goes away with that. And then 6 times 5 is 30, times 7 is 210. And then we just have to times that by 4 and times it by 9, and we'll get our final answer, which I guess you could just do in some kind of column with a 36 here or whatever. It's up to you. But anyway, that's going to be the general idea. Let's get into some questions then. And all these questions appear quite late on into all the into the papers, these 3 examples that I've got here. So, okay, find the coefficient of x squared y to the 4 in this. Now, just be a bit careful here. To get x squared, you obviously need to take 2 of those. To get y to the 4s, you only also need to take 2 of those, because, of course, 2 of those will make y to the 4. So we need 2 of those, we need 2 of those. That's 4 things selected, which means there are 3 things left to select, which means we must be choosing 3 ones. So that's what we're going to do, and that will, of course, be 7 factorial over 3 factorial, 2 factorial, 2 factorial, because that's the number of each we're selecting. We actually just calculated this on the previous page. It's 210, and we get that question done very, very quickly if we know this little trick. So that was a 30-second question if you just know how to do that. They have asked slightly more complicated things. Like this here, we've got two things to do. Let's do the easy one first. So we're looking for coefficient of x to the 4 in this expansion. Of course, that involves taking two of those. Let's just do normal binomial. It's 5 choose 2 times 1 to the power 3, not that that matters, times this squared, which is a squared x to the 4. The minus doesn't matter because I'm taking two of them anyway. 5 choose 2 is 5 factorial over 2 factorial, 3 factorial. 5 factorial and 3 factorial cancel down to 5 times 4. Divided by 2 is 10. So this is going to be 10a squared as the coefficient. The x to the 4 doesn't matter. Now let's do this one here. We need coefficients of x to the 3. So how are we going to get that? Well, there's actually multiple choices. You could either take one of these and one of those, because they all combine for an x to the 3. And that leaves, of course, with 6 brackets, that leaves 4 of them to take. So it's 6 factorial over 1 factorial, 1 factorial, 4 factorial. However, because we're taking one of these, that's going to include another 3, and one of these will include another 2. So, okay, 6 factorial over 4 factorial is just 6 times 5, which is 30, times 2 is 60, times 3 is 180, and that will be the coefficient for that choice. However, the other choice is to take none of these and take 3 of those to get an x cubed, and then, of course, you need to take 3 of those as well. So the coefficient here will be 6 factorial over 0 factorial, which is just 1, 3 factorial, 3 factorial, and then, of course, because we're taking 3 of those, we also need to do this is going to be 2x all cubed, that's times 8, or times 2 cubed in our calculation. Now, of course, this is 6 times 5 times 4, once you cancel all the rest of it with that. And of course, this is 6, which just leaves a 5 times 4, which is 20. Again, that's the kind of thing you want to have going on in your head. Just takes practice. So that'll be 20 times 8, which is clearly 160. And that's all there is to do it. That's the only choices I have. So let's add these two things together to get 340. The coefficient of x to the 3 here is, which is from here, that's twice the coefficient of x to the 4 here. So I need to do this times 2 is equal to that. Divide everything by 20, you get this, root it, and you get plus minus root 17 as our answer. That was question 19. So that was supposedly a hard question. With this trick and a bit of organization and a bit of practice, it's really not that hard. If you want to do some practice of this, just literally write your own question, answer whatever part of it you want, and then just type it into Wolfram Alpha and check if you're right. You can just write your own questions here if you need some extra practice. Anyway, we'll do one more here together. Coefficient of x squared. Now, okay, we've got a bunch of things going on here. So the two options for making an x squared are to do 4 times the x squared from this guy here, or do x squared times the constant term from this here. But if you look at the constant term, 1 to the power 6 minus 1 to the power 5 is just 0. So there's no constant term in this bracket here. So actually, all I need to think about is 4 times the x squareds from here. So okay, let's look at the x squareds from the triple one first, because we've just been practicing this. X squareds from here, there are two choices. You either take one of those and none of those, because you've already got the x squared, so none of these, and therefore 5 of those to get to 6 in total. And that will, of course, be 6 factorial over 1 factorial, 0 factorial, 5 factorial. And then you're taking one of these, so you're also going to have this extra 3 on the end from there. Of course, 6 over this, that's just 6. All of this times 3 is 18. So that will be our first one. The other choice is to take 2 of these, none of those, and therefore 4 of those, which is 6 factorial over 2 factorial, 4 factorial, 0 factorial, I guess, not that it matters. And because you're taking 2 of those, you need a 2 squared as well. Now, this and this is just 6 times 5, so that's 30, divided by 2 is 15. I guess then times by 4 is going to be 60, right? I don't know why my numbers aren't appearing. But that was 18, that was 60, so that makes 78 x squared in total. And from here, there's actually no x squareds, because if you take one of those, you're too big, and there's nothing to make it any smaller. So actually, the only x squareds are coming from this 78 here, from this bracket. Times it by 4, because remember, that's what we said we needed to do in the first place. 4 times 80 is 320. Take away 4 lots of 2 is 8, and we'll get our answer of 312 as our final answer. Thank you so much for watching. I hope that helps for next week.